Let's start with time first. This is what we covered a couple weeks ago. And just so we review some of the issues related to time in special relativity. And specifically, the issue is that there is no definition of time. And because of that, we have all kinds of problems in our understanding. Or not really our understanding, the explanations special relativists give for anything related to time. No definition, you have no explanation or physical interpretation, right? No mechanism. And here's the first one, okay? Summary of time. Father Universe does not recognize motion. Father Universe does not recognize time. What do we mean by that? We mean that Father Universe only recognizes location, existence, what exists out there, okay? Father Universe is every atom in the universe at a given distance from all others, okay? So all that every atom has, any atom has, is location. And if it has location, it's an object, in this case an atom, right? It exists. It exists pursuant to the definition of exist, which is objects that have location. Father Universe only exists in the present mode. He recognizes no motion or time. He recognizes only what we could call present now, related to time, right? Present now, a point in time. Eternity. Now is eternity, right? Location is eternity. Instant, moment, location. That's what it is. That's all that Father Universe is. Every atom at a given location with respect to all others. And one of the issues is simultaneity, which is one of the issues that special relativity brings up. In fact, it's probably the most important one related to time. And that's that the notion out there is that things don't happen at the same time, according to the observers. In other words, opinions. And that's a notion we have to tear down. We have to destroy that completely. No such monster in physics. In physics, all we have is existence. Every atom in the universe is at a given location. Whatever happens, right, happens within a single frame of the universal movie. Now, we use the word happens, but happens takes up at least two frames. But an atom can only be in one frame at a time, one location at a time. Can't be in two locations, two frames of the movie at the same time. So the issue is when there's some kind of action, we have to look at where the atoms were in a given frame. Not in the reference frame. Do not confuse that with mathematical reference frame. We're talking about the frame of the universal movie. Okay? And so we have here a way of looking at this, right? Here we have God taking a picture of Father Universe. And Father Universe is just every atom in the universe at a given distance from all others. Father Universe occupies, as you can see there at the bottom, only a single frame in the universal movie. What is that frame? That frame, you can say, is simultaneity. In other words, two atoms are there in that frame, and they're a given distance from each other. And then in the next frame of the universal movie, they both move to a different location and so on down the line. So we say simultaneity because that's a word related to time. We say that takes up several frames. But when something happened, like if there was an explosion and there were two explosions somewhere in the universe, and they happened within a single frame of the universal movie, in other words, the starting of the phenomenon happened there in a single frame, right? Then we do have simultaneity. It's what is inside a single frame. That is the definition of simultaneous, instant, moment, point in time, the present, the now, the timelessness, and eternity. They all mean the same thing. It's a single frame, location and existence. That's all that we have in a single frame. Okay, and we have here the universal movie, the simultaneity. Okay, let me show that here. You have an event happen. We have two supernovas there in frame number 632. Okay, And so the question is, the first atoms that started popping or whatever, right? They had a given location, a given distance from everything else in the universe in frame 632. That's when the supernova started. Okay, so there is no if, ands, or buts. It all happened within that single frame. It could only have happened within that single frame. Now what happens? The thing takes up several frames, this explosion, and the first observer there that you see closer to the two supernovas, he's closer to the one on the top, the supernova that's on the upper left. And so he's going to receive the light from that supernova before he receives the light from the second supernova, which is a little farther away. So you can see that in frame 634, he's receiving the supernova flash in his eyes, but he hasn't received the supernova flash from the second supernova. Okay. And meanwhile, the second observer, who is much farther away, he doesn't receive any of the light yet. Okay, because it hasn't covered the distance. Okay, so what happens in frame 635? Well, finally the first observer receives the flash from the second supernova. He's already seen the first one, and it turns out that the observer, number 2, he hasn't seen any of it yet. He starts seeing it for the first time in frame 636. But when did the supernova happen? Well, that simultaneously happened in frame 632. No one can change that. Not even God, not even Father Universe. It just happened in that frame of the movie. Okay, and so that's what you need to understand about simultaneity, about a point in time, about now, about the present. There is no such notion as time. See, they mix up all these notions. They mix up time, which takes up at least 2 frames or more, right? And they mix that up with what happens in a single frame, which is the notion of simultaneity or moment or, time, cross-section of time, point in time that they're going to analyze. And there's a contradiction there because an atom can only be in one frame. It can't be in 2 frames, okay? Unless you're in mathematical physics, where they say you branch off into different universes and you make a clone of yourself in every step you take. That's not the case in science. Okay? Now, here you have frame 632. That's when the event happened. Okay? That's when the 2 supernovas were starting to happen. That's where the atoms were in that frame of the film. Okay? So you can't change that. That's fixed. Atom can only be at one place at a time. Okay, and one thing you have to remember, Father Universe, because Father Universe is just every atom in the universe at a given location. It's a static notion. Father Universe does not remember the past. He has senility, you could say, amnesia. He goes to sleep in a given frame of the movie, right? And he doesn't wake up for 1 trillion years. When he wakes up, all the atoms now have moved to the next location. Then he goes to sleep for another 1 trillion years and so on down the line. So here you have him. He doesn't have a computer. He doesn't have a filing cabinet. He has no idea what happened in the past. Okay, Father Universe does not have memory. Okay, and that's one of the things that is required for time. You need absolute memory, to have memory. Same for motion. If you're going to look at motion, you have to remember where the object was, in a previous frame. And we record all that in our brains. And so we say, okay, we take motion for granted, right? And then we take time for granted. And it's not so. Every atom of your body only occupies one location per frame of the movie, okay? And when it's no longer, when it's at a new frame, it's no longer at the previous frame. And that's very hard for people to understand sometimes, okay? Okay, so here we have the way they see it in relativity. They think that you're creating new U's in every single frame. They think that the previous frame still is there, right? The previous location, your previous atoms in the previous frame, so that you can travel back in time, as they say, right? And meet yourself sometime in the past. No, that's Hollywood nonsense. That's got nothing to do with science or with physics. The way it works is the way you see that dot at the top, the ball at the top. It occupies many locations, but as you can see, there's no memory of what that of the different locations that ball had. The one on the bottom, on the other hand, you can see all the locations there. And special relativity looks at it like the way you see it at the bottom. All the balls leaving different balls in different locations so that you can go to one of those locations and stand on one of those balls. That's the way they see it. And you can see that in the film at the bottom. In frame 631, you see only you. That's you there. But in frame 632, you moved an inch or a meter or a foot or whatever, and there's two yous now. There's this previous you that was there, and it's in the same frame of the film as you are in now. And the same with frame number 3. Now you have 3 of yous, and so on down the line. So by the time you get to frame 636, not to mention gazillions of frames, right, in your life, every split second, right, you're leaving someone behind that's you. And so special relativity says that you can go to the past or to the future and see one of you in a frame because you're still here and so is that person at the same time because you're both in the same frame of the movie. And so, special relativity's notion of time has to do with math and not with physics. It has nothing to do with reality, with what is. It's just mathematical gibberish. That's all it is. And because of that, they talk about faster than light. And what's faster than light? Well, they need it for 2 reasons. One, to be able to go to the past, right, or to the future, and also to visit a black hole or a wormhole or whatever. But the other one is so that they give you hope that we can get out of the solar system someday. If we can go faster than light, not only can we reach Mars in very short time, but imagine going to the nearest star, Alpha Centauri, the Centauri system out there, 4.3 light years away. That's traveling at the speed of light one way, you reach 4.3 years, right? And coming back, round trip, rounding off, you just talk about 9 years. And that's too long. Nobody can imagine that happening. People traveling for 9 years, back and forth, for what? Will anybody fund such an operation? Or project? So what they do is they say, but we can beat the speed of light. And for that, they needed faster than light, right? So they created all these mechanisms. And the big problem about that is that it's in the literature. That's the big problem. I mean, if they want to talk about that in Hollywood, no biggie. You can invent anything in Hollywood, make, special effects and say, hey, this person travels faster than light, or, take the Enterprise and just beam me up or down, Scotty, right? No problem. That's magic. And magic is okay where it belongs, but not in physics, not in science. And these people are bringing all this magic into science to beat the speed of light, which they all acknowledge after studying 10 years at the university, right? They all acknowledge that nothing can beat the speed of light according to special relativity. And then they want to overrule it. They want to skirt it. They want to circumvent this limit. They don't like that limit. So here it is. This is essentially it. Summary of faster than light. Faster than light is for Hollywood special effects. It's nonsense. It's good for, science fiction, fantasy. That's great. But it's unscientific. Don't bring it into science. Don't bring it into physics. Don't bring it into the scientific literature, which is what these people do. Okay? FDL should not have been there in the first place. Who approved this? Who were the peer reviewers who approved faster than light? When they all know, they all study, they all memorize, they all read the catechism of special relativity in general, right? That says that nothing can travel faster than light. They don't know why, and that's maybe why they try to skirt it, but they all have to, put their hand in the Bible and say, hey, I swear to God that, light doesn't travel faster than 300,000 kilometers per second, little c. And so we have a problem because on the one hand, they all swear to God that it can't travel faster than light, nothing can travel faster than light, but then they immediately write papers that get published where they circumvent the speed of light or show mechanisms and whatever. Why? Because they want to be able to travel outside the solar system. If they can't, then we're all dead here. This is our tomb here on Earth, right? No tachyons, wormholes, or warp drivel, as I call it. They call it warp drive, I call it warp drivel. That's what it is. It's all drivel, all this stuff. How does any of this stuff make it to the literature? That's what you got to ask yourself. I mean, if they want to talk about it at the bar, at the water cooler over there in Harvard or Cambridge or whatever, go ahead. But don't bring it into science. How is this stuff approved for publication? That's what you got to ask yourself. And it's done with your money. Okay? Very important. All these people are funded, to study this stuff, to create equations for this nonsense, none of which exists. None of which has anything to do with reality. So are we paying these guys to just develop, equations for inexistent stuff? Unicorns and leprechauns? Is that what they're developing equations for? It's only to use to give hope for escaping the solar system, right, our planet. And then in order to do that, they have to create negative mass, negative energy, negative time. They create all these negatives. Yeah, if you weigh minus 20 pounds, whatever that means, right, I guess you can travel faster than light. You'll probably be floating up in the air, right? I mean, it's nonsense. Absolute nonsense. What is negative mass? What is negative energy? How does this stuff make it to the so-called scientific literature? And yeah, these irrational ideas only have the purpose of circumventing special relativity's maximum speed limit. They don't like the fact that light has a speed limit and that they cannot outrun it. They absolutely detest that. They want to have something to do also with their equation. They say, well, what if we put a negative sign? What would happen then? Yeah, I mean, you can put a negative house. What does negative house mean? It means that you don't have a house, or you have it only in your dreams. I mean, what does that mean? And under the rope model, we can see why the speed of light is not only a constant, but why it's so fast. We can show both of those graphically. You don't need to go to college. You probably don't even need to go to high school. A 5-year-old kid can probably understand it. So here it is, okay? That's what it is, the electromagnetic wave that Maxwell and all these people in the 19th century came up with. We're replacing it with a rope, a pair of twined threads. A thread is not a field is not a thread, so we're not just making words here. Field is what you see there. Bunch of vectors, numbers. What's a field? Values at each point in space. So both field and vectors, of which fields are made, right? They're all numbers. That's all they are. And yeah, because this came out of mathematics. So when you look at a wave, and especially when you see it flying by you, very scary stuff. But when you see a wave, you're looking at a mathematical concept. You're not looking at a thing. You cannot say that light is a wave or is mediated by a wave, because a wave is what you see there, a bunch of numbers. That's all a wave is. We're replacing that with a physical object. We're saying light is mediated by a pair of twined threads that look pretty much like DNA. Okay, that's what it is. Okay, and so the speed of light is fast because you have a torsion instead of an up and down transverse wave. That's the first issue. Torsion, prove it to yourself, fastest wave known to man. In fact, it's the fastest thing that you can imagine. There's nothing faster than a wave, than torsion on a rope light, two-strand rope. Superman, the Flash, none of them can beat a torsion, because the torsion is already connected at the other end. The rope is connected, or the mediator is already connected at the other end, whatever it is, right? It looks something like this, okay? So you can see that, you don't have to travel over there. It's already over there. As soon as you turn this, the other end is already moving, okay? So that's why light is so fast, because it's a torsion wave, not a transverse wave. Transverse wave, in fact, is the slowest wave known to man. It's slower than a longitudinal wave. Longitudinal wave just has to go back and forth, whereas the transverse wave has to go up and then come back down. So, when they have these seismic events, they measure, which generate both longitudinal and transverse waves. The longitudinal waves travel 1.7 times faster than the transverse waves. So we know that longitudinal waves are faster than transverse waves, which they say is what light is, right? So light should be slower than sound, I guess. You hear the thunder before you see the lightning, that kind of thing. So something is wrong with the transverse wave. You can't use that. And that has to do with speed. Now, why is it a constant? Well, you can see there, little c has been measured billions of times, okay, confirmed that it's a constant. Travels 300,000 kilometers per second, rounding off, right? And it's equal to an inverse relation between frequency and wavelength. That lambda, that's wavelength, right? And so you have the little f and lambda, right? And when one goes up, the other one goes down, and vice versa, to keep the little c constant. That doesn't happen with all waves. Okay, keep that in mind. You have sound waves, all these others. They can go, not sound waves specifically, but other waves can go faster than, in other words, there's no inverse relation necessarily between frequency and wavelength. You can raise both the frequency and the wavelength, and that wave will go higher. But little c is different than just velocity of a wave. Little c is a special type of speed, and it's known as a constant, known as 300,000 kilometers per second. So little c is a constant, and frequency goes up, wavelength goes down, and vice versa. And you can see why. There you have 16 on the bottom, 16 links, okay, making up that rope. And if you untorque it, you see the inverse relation. Now you have fewer links, and each link is longer. So the wavelength has increased, link length, and there are fewer links, and vice versa. Okay, and that's why not only does it explain the speed of light, but also why light is a constant. The only entity that can simulate the speed of light, mediator for light, is a rope-like mechanism. Two-strand rope will probably do. Okay, so that's what we're proposing. Here we have the construction. Looks more or less like that for not only the light, but an atom. So you have an atom, and what you have is one thread goes around and builds this ball of yarn that encapsulates the other thread from every rope in the universe that converges upon our atom. And one thread goes through the center of the atom, the other one just goes around and encapsulates it. And that's what our atom looks like. So there's no attachment between the rope and the atom as if they were two separate entities. No, one turns into the other, and then on the other side it continues, going to another atom, the rope. Okay, so that's the construction quickly there. So you can see what we're proposing. Here's the basic system that we're proposing. We're saying there's two atoms there, and they're connected by a rope. Okay, very thin, unimaginably thin threads. Okay. So here they're very, very big, but this is the best way we can illustrate it. But you have to think of this as the atom being the size of the Earth, and the threads that make up the rope are the size of your sewing needle, okay, compared to the Earth. More or less like that. That would be a better relation for what we're talking about. But anyways, we have these pair of twined threads. They unite any two atoms in the universe. So that's our basic system. You can imagine this as being connected to tons of other pairs, right? In other words, a rope extends from each one of these atoms to other atoms and so on down the line. And so that's the basic system. You see the 2D version, the 3D version. The atom expands and contracts, and when it does so, doing its quantum jump, it torques the rope. Why? Because the rope is part of the atom. It's an extension of the atom, you could say, right? It's not a separate entity. It just flows from it. Okay, so that's our proposal, and one last one so that people see why you don't add the speed of the train to the speed of the light coming out of the train. In other words, you have your car, you turn your headlights on, and the speed of light will be always 300,000, be measured to be 300,000 kilometers per second, no matter how fast you travel, or even if you're standing still. And here's why: because every atom, as you move, eats into the rope, which makes up the atom. Okay, so all you're doing is sliding like a bead on an abacus. Okay, you're not pushing on the rope. In other words, the rope is going through you. Okay, so you're eating into the rope that makes the atom, and multiply that times gazillion atoms in the universe, and you get an idea, how this system that we're proposing works. Very easy stuff, really. It's kindergarten stuff. Once you see pictures, it's easier to understand than to go into math and trying to figure out, what does that equation really represent? The math is good. It's good. It's good to have that math in the background because it gives you a description, right, of how things move, how they behave. But math cannot tell you what is. And that's the problem with all of mathematical physics. You won't find a single entity, a single object in all of mathematical physics. That's the problem. What you have is descriptions of motion, quantitative description of motion. You never find a single object. Field is not an object. Energy is not an object. Mass is not an object. Time is not an object. But they treat them as such. They bend time. They move the mass. They vibrate the field. They transfer the energy. They think it's a ball or something. Okay, so that does it for time, more or less.